20 computers are being shipped out, and here's some boxes to represent my computers. If the shipment had 3 or more defective computers, we don't want to ship it. That'll look bad for the company, look bad for our quality control. Now we don't have time to test them all. We're only going to test 4, and based off that test sample, we're going to try to project whether the shipment has more than 3 bad or if it would be okay to ship. So first of all, let's try to figure out how many possible ways are there to select 4 computers from this batch of 20. I mean, you could just take this row, that's one way to get 4. You could be grabbing this row, that's another way to get 4. Or maybe you take the first 4 in this column. Or maybe 2 here and then 2 at the end. There's a lot of different ways to get 4. There are 20 computers and we're choosing 4 for a group. There's in fact going to be 4,845 different ways we could select 4 computers from this group. Now we definitely want to use combinations and not permutations because the order doesn't matter. If I selected these 4 to test and I pick this one, and then this one, and then this third one, and then this one fourth, that would be the same batch of 4 computers as if I started on this side and picked this one first, this one second, this one third, and this one fourth. Either way, I'd still be testing the same group of 4. So since order doesn't matter, we're using combinations. So there's this many different ways to select 4 computers, and let's say my batch of 4 has 2 defective. So I'm really concerned now, are those the only 2 defective? What's the chances that those are the only 2 defective? Because remember, if there's 3 defective or more, I don't want to ship. So out of all the different batches of 4 that we could possibly get, there's 4,845 different ways. We know our batch has 2 defective. We grabbed both the bad ones. So really what we need to figure out is how many of our batches of 4 have 2 defective and then 2 good. Because that's what our batch ended up having, 2 defective, 2 good. So a way to calculate that, we know we're picking the 2 defective, that's a given. How many different ways are there now to select 2 from this group of 18 to complete the batch? I have 18 remaining good ones, and I need to select 2 to complete the batch. It could be these 2, could be these 2, it could be any of the 2. But how many different ways can I pick 2 to complete the batch of 4? And there's 153 ways to do that. So out of this total right here, there's only 153 of them that are going to have the 2 defective and then 2 good. So the probability of drawing that is right around 3%, which is pretty low. So if I was in charge of quality control, I would be a little skeptical that these were the only 2 defective computers, and I would not ship the batch.